I would like to seize the moment and to express my thanks and appreciation to Dr. Amorous and Dr. Nolan for allowing us to present our paper. So, all of us live on the planet Earth and solar system. Many a man dream to visit other planets and to come back. But nobody of sane people dreams to fly to another stars and galaxies. The same people understand that it is impossible due to the existing barrier made by the nature itself. I mean the boundedness of the velocities of material bodies. In and after talking about the velocities, I will keep in mind the magnitudes of the velocity. So the velocity of material bodies cannot exceed the constancy c, which equals the speed of light. The same people understand that due to the colossal distances between stars and galaxies and due to the relative low velocity of movement, it will be never possible to travel the universe to the galaxies and to come back to the relatives and friends. It is thousands pity, but this picture is a fantasy, and the episode like this one will never be a reality. Why is the speed of light finite? And why cannot the velocity magnitudes of material bodies achieve the speed of light in a vacuum? Why are material bodies fated to move at a velocity lower than the speed of light? Many people, especially professionals, believe the statement of the question of the cause of the finiteness of the velocity of tangible objects is incorrect. In the opinion of the proponents of this point of view, the fact of the finiteness of velocity should be taken as a certain, given without the question why. Yet in our paper, we still presume to identify the cause of the finiteness of the speed of light and the cause of the boundedness of the velocities of material bodies. In the paper, there are no complicated mathematical calculations. Perhaps this is one of the simplest articles that you have read or listened to. However, this simple work provides answers to the complicated why questions, which according to the popular opinion do not make sense and therefore do not have any answer. So, before to answer these questions, we have put another question. We asked ourselves, what would happen if the speed of light were infinite? And we got a paradoxical answer, which reads as follows. In the case of the infiniteness of the speed of light, provided that it were infinite not only in space, but also in material bodies, the speed of light would be finite. I would call this property of finiteness and infiniteness of speed of light duality of finiteness and infiniteness of speed of light. Light-speed duality is the concept that the photon exhibits the properties of not only finiteness but also infiniteness of speed of light. So, having realized that the fact of finiteness of speed of light does not contradict the assumption of the infinity, we reveal a cause of the finiteness of the speed of light and of the boundedness of the velocities of material bodies by the speed of light. It was achieved without references to the provisions of the special theory of relativity. This cause is equality of signal speed in empty space and in material bodies. If the speed V large of massless signals and in space and inside the bodies is equal, then the speed of massless signals in each case is finite. It is finite even if we assume that it is infinite. So the topic of our paper is why the velocities of material bodies cannot achieve the speed of light in a vacuum. So the velocities of material bodies cannot exceed the speed of light in a vacuum, and this is assuming that the speed of light itself is not so great. It is not great, at least for elementary particles, that we can lightly accelerate to velocities only slightly lower than the speed of light. For example, we can lightly accelerate an electron to the velocity of 0.99 c, speed of light. But we cannot receive the speed of 1.1 c, even if we will accelerate the electron in an electric field all our life. So, what is the reason that a material body, no matter how and how long it is being accelerated, never achieves the speed of light in a vacuum? The inability of tangible objects to achieve the speed of light doesn't fall within the framework of everyday common sense, and is generally explained by the prohibitions against this movement that are contained in the special theory of relativity. However, such explanations only make it possible to state the fact of the finiteness of the velocity of tangible objects, and do little toward making its underlying causes comprehensible. So, a very important question. Why does the speed of light, being finite, behave as if it is infinite? What do I mean when I say it behaves as if it is infinite? First of all, I mean that it is impossible for a beam to catch up. Then I mean that the speed of light in reference systems moving relative to one another is identical. Lastly, I mean that in this case, physical bodies cannot achieve the speed of light. What would be if the speed of light c were infinite? None of previously mentioned questions would exist if the speed of light were infinite. It would be impossible for a beam to catch up due to the infinity of speed of light. The speed of light in reference system moving relative to one another would be identical due to the infinity of speed of light. Physical bodies couldn't achieve the speed of light precisely because it's infinity. But alas, the speed of light is finite, and this is an undisputable experimental fact. So, what is the cause of this strange situation? In our paper, we postulated a condition during the satisfaction of which the fact of the finiteness of velocity becomes obvious and even stops contradicting everyday common sense. This condition is as follows. Interaction signals and carrier particles that have no mass are always present in material bodies. These interaction signals and particles being propagated at a velocity v large that is unattainable for physical bodies and particles that do have mass, continuously initiate interactions and processes in this body. Please pay attention. We don't say that in this condition that the velocity v large is equal to constant c. We say only that the velocity v large is unattainable for physical bodies. We don't prohibit the equality of the velocity large to the infinity. In other words, the condition consists of the presence of massless interaction signals and carrier particles in material bodies that are propagated at a velocity v large greater than any arbitrarily prescribed velocity v small of the material bodies or particles that do have mass. How to understand the condition? Let us, temporarily skirting the prohibitions of the special theory of relativity, assume that the velocity of physical bodies and particles can be equal any arbitrarily prescribed values. In order to satisfy the requirement of the unattainability of the velocity of massless interaction signals and carrier particles by these bodies and particles, we will presume that any arbitrarily prescribed velocity v small in all our speculations is less than the velocity large, than the velocity v large. I want to say, we mean that we say about the velocity that is, it is not infinite velocity. If we have two events in point A and point B, and the event in point A causes the event in point B, then it is so the time between these two events is not equal 0. It can be very little, tiny, but not 0. You understand? Yes. So now, during this assumptions, we are committing the transgression of the fact of the limitation of the velocity with the constant of c. But we can justify the transgression by way of the fact that we are not solving a physical problem, but rather are attempting to logically prove the inconsistency of the assumption of the movement of tangible objects at a boundless velocity. So now the question: can we, by satisfying the condition mentioned above, conceptually dispatch a free moving signal or solid body to point A, located a distance of L from a certain material body at rest, at a predetermined velocity, and bring it back in such a way that they almost instantaneously fly to and fro, traversing a distance of 2L in this instance? At first glance, we can. After all, we are able to assign the body any v small velocity. And according to the condition we formulated, the v large velocity of a signal is much greater. But before we rush to judgment, let us ponder the content of the concept of instantaneously. What does instantaneously mean? In the metrological sense, instantaneously means a zero variations in the readings of an arbitrarily precisely running clock between the times when a body or signal is dispatched and it returns. In the physical sense, instantaneously means that no processes and variations occurred between these times, even at the micro level. The dispatch time and the return time must merge together in this instance. After all, if any processes and variations occurred in a body between these times, then by occurring in time, the processes and variations required a specific amount of time. This means that the times of dispatch and return are separated by a time interval to which the arbitrarily precisely running clock must react by a change in its readings. So we now wonder, is it possible for an arbitrarily fast-moving body or signal to traverse a distance of 2L while no variations occur in a body at rest? No, this is not possible if there are interaction signals and carrier particles in the body at rest that are propagated at a velocity of v large and that initiate events. Let us remember that everything changes in at the macro level in material bodies without stopping for even the tiniest period of time. Interaction signals and carrier particles that exchange the elements of material bodies are responsible for many processes and events in these bodies. Being found in material bodies in a state of motion at a velocity of v large, according to the condition we formulated, interaction signals and carrier particles initiate the accomplishment of events. If the average distance lambda between material bodies elements interacting in a certain way is considerably less than the entire 2L path, then when a massless signal moving to point A and back cover a small part of this path, it is path it is traversing, which equals lambda. Each of the event initiating interaction signals and carrier particles of a specific time present in a body produces an interaction in the mean statistical sense. However, during the time of travel of a signal to point A and back, and its traversal of a distance of 2L, 2L over lambda times more events of a given time are accomplished in a body at rest than when traversing a short distance equaling lambda. But if there are interactions in a body, the body then changes in time, and arbitrarily precisely running clocks must react to these changes by way of a variation in readings. So let us imagine that in this table, the interaction massless signal are propagated between some elements of the table. We don't know what is it. It doesn't matter. The interaction signals are propagated with the speed v large. So the speed v large is arbitrarily great, not infinite. We can say infinite. And colliding with the elements, the signals produce events in the table. Yes? There are very, very many signals in the table. The average, we can say that in a the mass concentration of interaction signals is n sub m. It is a quality of interaction signals in a unit of mass of our table. So the average free path of the signal equal, okay. So now let us dispatch a free moving massless signal in the space from our table to the mirror placed on the moon or on the Mars or on the Jupiter, doesn't matter. After the signal reflected from the mirror, let us bring it back to our table. Can the free signal instantaneously fly to and fro, traversing the double distance to L between our table and the mirror? In other words, can the signal fly to the mirror and back while no variations, no events occur in the table? No. The mean free path of the signals inside the table equals lambda. If the free signal in the space traverse a little, only a little distance equal to lambda, then each interaction signal in the table produces an event in the table. You understand, yes? If this free signal goes only lambda, then in the table each of the signals produce an event. So if the mass concentration of the interaction signals in the table equals Nm, so here, then Nm events accomplish in a unit of the mass of the table. It is if the free signal traverse a distance lambda. So n sub m events occur in an unit of the mass of the table if the free signal in the space traverses a distance equal lambda. But our signal in the space traverses the distance 2a. It is more than lambda in so times. At a velocity v greater than any prescribed velocity v of the material bodies or particles that do have mass. It is mathematically right, but it is physically wrong, because we cannot prescribe the velocity to any prescribed velocity to the material objects. But we can change this condition and write so as it written down. We changed the word prescribed so to the word achieved, and then this condition is absolutely correct. You cannot. So if I don't know, so I don't know that the speed of light or the speed of signal is finite, then I say so. You can achieve a velocity. I don't know what it is speed, but I think it can be infinite. Yes, I don't know. But if I think about what I said, then we shall understand that it cannot be, that the speed of light cannot be infinite. I think that if you will read our article, our paper, you will understand it is better written than I said. It is translated with good translators. So, no, I think it is not so interesting. We simulated this. I think I shall read conclusion. The speculations presented in these articles can be tied to any inertial reference system by virtue of the formal equality of these systems. We initially examined the conditions under which the velocity of material bodies has a limited nature based on the example of the model. The model is the simulation of the special theory of relativity. We later departed from this model and made the transition to the examination of the question independent of it. However, the considerations set forth in the aforementioned works in particular impelled us towards the logical solution of the problem of the finiteness of velocity and made it possible to answer the questions arising during the resolution of this problem. The results of our work may be useful when discussing the subject of superluminal velocities, which recently again captured the attention of specialists in the wake of questionable publications concerning experimental observation of these velocities. I think that's all. I'm very glad if you something understood you explain. But I think if you not understood, because I speak very bad English, you will read our article and you will understand. And then read our simulation too. Okay? If Oleg wants to say something, then he can.
The faster outside, the faster inside. That's very easy. The material body, the faster light goes outside the body, the faster it goes inside the body. And this that creates an achievable speed of light. That means the body changes in time. That means
if the speed is infinite here, and then we send a signal there and to and fro, yes, then this signal he flies with infinite speed too, and then he makes events there, and we cannot nothing do. If it is infinite, then we shall have a lot of events in the body.
As I understand your argument, it seems to me it's parallel to an argument that I heard elsewhere to the effect that if the speed of light were infinite, that the universe would freeze up and there would be no motion. That all mass would be just one solid.
No,
I think the delay in the speed of light makes variation, makes dynamic.
Otherwise.
Otherwise, if the speed of infinite were infinite, then our world would very soon change. Yes, I said so. If the God looks at us, yes, then he sees all he doesn't wait.
Everything goes very fast. But we can see that because...
But it goes so fast,
yes, he sees
it becomes absurd, and therefore the only admissible solution becomes that the velocity, the universal velocity of everything is zero. In this other argument, it's not my argument, so I don't know the details, but I remember reading. But it sounds.
To understand it, yes, we must take, as I said, the time of God. If the God sees, then. But there is no time of God. It is only our time, and in our time we have always only the finite speed.
Like in a computer quartz resonator, it creates events, starts processor. This way, particle, let's say,
I fell off the set on the read work. You came just about it.
Events in the body, they are going with the same speed. That's in the basement of the model.
Yes.
Can we pull the speakers before questions?
Electric waves or transmissions. There's transverse and there's longitudinal. And longitudinal transmissions are made by every radar system in the world, and also by every cell. Living cells give off longitudinal light. And in electrodynamics, the equations for longitudinal light do not have c in them, so it is assumed that they go faster than the velocity of light, transverse light. But we have not measured it because the instruments that can measure longitudinal light are not real suitable for measuring its speed. And so, as far as I know, they haven't made any really accurate measurements of that. But I don't know how that affects this. If you had one component of light that goes faster than the other component, what does it do?
It is only explanation why. It's only explanation. It is so as
It's like Zenon.
Zeno's paradox.
yes,
Zeno-
Zenon's paradoxes. I think it is something near to Zenon's
Of same sort.
So, yes, we can logically show that the speed of light cannot be infinite.
Look at
Even
it from-
if we think that it is infinite, that's all.
Look at it from the
nothing
point
more.
of view of coupled equations, coupled dynamic equations. And classically, they're coupled together with an infinite speed.
Yes.
Have two equations. And in relativity, however, they're coupled with delay. And I think if you had an infinite number coupled, it sounds to me more like you have a frozen universe than that the only solution, the only particular solution of the system would wind up being one in which nobody does anything.
Yes, I thought about it. I cannot explain
No,
it
you
in
know,
English,
yeah.
yes. So, it doesn't need that something flies in between this. It can be virtual infinity.
Yeah.
Virtual infinity.
I'm not
Virtual,
sure.
perennial. So,
Comment. Oh, sorry. Go ahead, Val.
I mean, is this just an imaginary thought experiment, or is there some real place where you can think of infinite speed, infinite mass, or infinite anything?
если он говорит,
Он спрашивает, это значит, это просто воображаемая модель, значит, или есть какие-то.
I think it is mathematical model, or not mathematical, logical. Can be logical. Logical.
Yeah, but mathematics
don't-
is a language.
I think if they are mathematical, then they shall do it better than I. Yes, I think it is not so good in mathematical sense. So.
See, I think you can lie in any language. Mathematics is a language. And, it makes no difference.
Is that Gödel's theorem? Gödel's theorem.
Yeah, whatever.
Every language is necessarily incomplete.
Yeah,
Just as every
but
algebra
I
is
mean,
incomplete.
Why should one language have a monopoly over always telling the truth or always telling lies? They both are equally capable of expressing.
Mathematical language, not also, yes, also.
Yeah.
No, yes.
Because I know a lot of mathematics which
I agree.
explains reality
I
also.
agree.
But you can lie also,
But
just as
nature eventually, in physics, nature eventually decides through experimental verification of mathematics.
well, I mean,
Mathematics is invented here.
It's a
It's
useful
not observation,
tool.
it's an
But it's
idealization.
not a question
Nature
of lying
decides.
or using a concept that couldn't be physical.
No,
It's
lying is
possible,
not.
it's possible that a signal, an event happening here, something happening here is known immediately over here. It's possible,
Yeah.
right?
Of course,
So,
but not,
so if you
not
go
through
through the
this
logic and
analysis.
show that it can't be done in a certain circumstance, you've achieved something, right?
Yes, but I mean, you really have to get in a ballpark which is different than what we have been discussing. We're not in the right domain when we do these thought experiments without getting in the ballpark correctly.
I'm not
We're
sure
not
what
in the-
your-
we're
I
out
don't
on the
understand
left
what your
field in thought
objection is.
experiments and just trying to amuse ourselves. And that's why I bring up the point.
Well, but consider, for example, entanglement situation.
Of course, I believe in-
Where I know that if I find out a certain
Yeah.
piece of information here, that information is in fact
Right,
available over
but
here.
nothing like
then-
travel.
But then we can ask, did a signal get sent, right? So,
No, that's
so
right.
their argument shows, for example, that a signal did not get sent.
Signal, but the information is there.
Well, maybe it was just
Information
put there
is one
earlier.
thing, sending a
Maybe it
signal
was just
is
put
another.
there, the question is whether there was a common
How can it
cause.
be put earlier Unless
There's
you have a
common cause, and
mechanism
entanglement
for
is a
doing
common
it.
cause. Their claim, the standard story is there's no common cause, that the information is transferred. But if there's a common cause, then there's nothing mysterious about correlation.
What do you mean by common cause?
Two things once upon a time were together, and at that time they interacted, and then they spread apart.
Yeah, but
Like you and your sister have the
infinite
same,
speed.
have the same maybe eye color or something.
Well, Einstein did the experiment. And
Didn't
he
do
had
any
to have
experiment.
yeah, at Los Alamos, and they had tachyons were invented to explain how information was transmitted faster than the speed of light.
Yeah, but they didn't do it.
Well, the experiment was done.
They may have talked about it, but
No,
they
the
didn't
experiment
see,
is
nobody
done.
has seen anything going faster than the speed of light.
They didn't see anything
No, of
going,
course,
they
that's
just
a comment.
reasoned it had to be.
Yeah, right.
Right.
If you make a
But
mistake in your reasoning,
it
you
has to do
can
with
get
Bell's
that.
theorem, Bell's inequality, and all the test of Bell's theorem up to kilometers. If that entanglement, and I do agree with the idea of a prior cause, that maybe there's a prior cause, but as the two particles go out, it looks like they're superluminally connected. So I mean, that's an issue to discuss,
Well,
how you interpret that.
if those two particles were one in the same wave equation,
Oh,
and,
that's a good
and
point.
they apart, that one in the same wave equation never changes. You know, there's some of those
That's
two wave
true,
equations, so
because
that's where the entanglement
It's clear
comes
that
in.
non-locality exists, and that I think is a big revolution in physics.
If it's
A
true,
huge
right.
revolution.
If it's true.
As big as the Heisenberg uncertainty principle. And you're right, if you maybe think of that, but I think what we're trying to do is take and match mathematics to a conceptual framework that we can test experimentally, but it's also the interpretation of an experiment, because there's various interpretations of that.
But nobody's seen anything going faster than the speed of light. They've seen a verification of a statistic that they interpret as meaning something.
That I actually think I think this is the crux of the matter and the conundrum of what that really means, a superluminal signal. Tachyons in the complex space are consistent with the standard model. However, is it something you call physically real? And it still seems to be an interpretation which is grappling with really the nature of quantum mechanics, which is, you know, how do you conceptualize little electrons as balls or billiard balls or waves, you know? It still gets into the fundamental of how we make a mental picture of what we see experimentally and how we interpret that.
I think we have to move on, and it looks like an interesting topic for discussion over the banquet or other coffee breaks. Another round of applause.
Thank you.